All right, this is lesson 68. So since I'm not going to be in class this week, what I'm going to do is I'm actually going to do the lesson for you so you can follow along on how I do each part. This will be a great review of how to do each problem. This will be, hopefully I can do it in a fairly quick order and not yap too much. But let's start with the practice problems. Practice problem A. This is 1 over W plus C over W equals 1 over C. Actually, the lesson 68 is primarily how to do these complicated ones. And the answer is, like we did before, is when you have what's called a compound fraction or something over something, it just means this top part divided by this bottom part. Well, let's do that. Well, what's 1 over W plus C over W? Well, that's just 1 plus C over W, right? That's the top. Divided by the bottom, 1 over C. Well, we know that in math, we never do it that way. We say 1 plus, the fraction is never divided by fraction. It's always multiplied times the reciprocal of that fraction. So this becomes then just C times this, which is, you can write it as C times 1 plus C over 1, W times 1, W. That is the answer. So that's A. Another way you could multiply this out and say C plus C squared over W, because C times 1 is C and C times C is C squared. This is typically how you leave it, but this is perfectly fine as well. Okay, that's practice problem A. So I'm going to go through this lesson, and I'm just going to rush right through it and show you how to do it, and you can always go back if I go a little too fast. And let's move on from there. B, 1 over M plus 5 equals 2 over M minus X over M. Okay, same thing. On the top, I'm going to make this divided by that. So I get 1 plus M. First of all, I need a common denominator, so I'm going to multiply top and bottom times M. So I get 1 plus 5M over M on the top, divided by, these already have M's on the bottom, 2 minus X over M. Well, that is not good. 1 plus 5M over M. I don't divide fractions. I multiply times the reciprocal of fractions. So think of those. They're all kind of together. But notice, M over M cancels. So I'm going to end up with 1 plus 5M over 2 minus X. That's practice problem B. And that is the answer. Practice problems C, and then moving on to the others. Let's do it. And you'll notice as I go through these, I may make mistakes. I'm just going to kind of go through and do it. So this is practice problem C. A, x to the negative 1 plus b, y to the negative 1 over x to the negative 1. And I'm going to simplify that. Okay, so that is a over x plus b over y over 1 over x. So first of all is taking and remembering that anything to the negative power is just the other side of the fraction with that letter. So it's 1 over x is a to the negative 1, or x to the negative 1, and y to the negative is 1 over y to the positive 1. All right, so now I have a over x plus b over y. I'm going to multiply top and bottom times x. This one top and bottom times y, so they have a common denominator, and I end up with ay plus bx over xy. That's on the top. That's that. Divided by this, or times the reciprocal of that. So I have this thing, and these x's will cancel. So I end up with ay plus bx over y times 1. That's the answer. That's how you do it. And go back over that if I went too fast, but that's the deal. Okay, next. Okay, if a number is multiplied by 7 and this product is increased by 42, the result is 87 greater than twice the opposite of the number. Find the number. Okay, what I normally do on this is a number is multiplied. So my number, I'm going to use x. So if a number is multiplied by 7, and this product, that means they're multiplied together, is increased by 42, the result, or equal sign, is 87 bigger than, so it's 87 plus twice the opposite of that number. What's the number? Okay, well, that's it. So I have 7x plus 42 equals 87 minus 2x. I'm going to add 2x to both sides. I get 9x. Those go away. Subtract 42 from both sides. 87 minus 42 is 45. So x is 5. The number is 5. And that's how we do problem number 1. Problem number 2. Catman's entourage joined the motorcade. Total number of vehicles increased 130%. The final count was 345. How many vehicles were present in the beginning? Draw a diagram to aid. So we have whatever he had, and you increased 139%. So 130% of something was going to be 345. So notice this is blank of blank is blank. So now doing it in math, I'm going to make that x. We're going to change percent to 1.3. That's 130. Again, remember, move the decimal 2 to the right. Times x equals 345. X is equal to 345 divided by 1.3. We take our calculator out, and we just do that. 345 divided by 1.3, and I get... the number is 265. Okay, and so that's the original number. And it says draw a picture that goes with that. Kind of what they're saying is, okay, here's your original number, and the original number is 265. That turns into 265 plus the difference between those two, which is 70, plus 70, or 345. Okay, that's a bigger one, if that helps. So this is 130% bigger than, this one's 130% bigger than this one. Not really caring so much about the diagrams, but I am caring about that you figure out the numbers. Okay, problem number 3. Problem number 3, a new drug saves lives but produces side effects. 30% of the people who took it, if 1,110 showed side effects, how many took the new drug? Draw a diagram to aid you if it helps. Okay, so 37% of the number of people that took this drug had side effects. And the number of people with side effects was 1,110. So the question is, how many people took the drug? Well, ta-da, that's the only thing you don't know. 0.37, x equals 1110. So x equals 1110 over 0.37. You take your calculator, 1110 divided by 0.37, and you end up with 3,000 people took the drug. Answer. Don't worry about the diagram. Number 4. Roland averaged 4 jousts per journey for the first 3 journeys. He averaged 8 jousts on the next 27 journeys. What was his overall average number of jousts per journey? So he did 4 jousts on his first 3 journeys, and he did 8 jousts on his next 27 journeys, and he did a total of 30 journeys. So that will give you your answer. So 4 times 3 is 12. 8 times 27, as you all know, is 216. Divide that by 30, and you end up with 228 divided by 30, which is his average of 7.6. That's how we do it. His overall average number of jousts was 7.6, which doesn't make any sense because you're either doing 7 or you're doing 8. But again, he did 3 and he did 4 and he did 8. So, but he did a lot of 8s. So the average doesn't have to be a perfect number because it's just an average. Question number 5. Galileo counted the number of falling stars that he observed each night of the week, and he has a data chart in your book. It says find the range, median, mode, and mean of those falling stars. Range, median, mode, and then also the mean or the average of them. And so the range is the low and the high. So the low of that number was 119. The high one of that number was 170. So the range is from 119 to 170 is 51. There's a 51 difference before them. The median is the middle number. And so if we look at his set of numbers, we've got 122, 170, 133, 134, 152, 134, and 119. These are all the numbers. When I find the median, I take the lowest one and the highest one. I cancel those. Then I go the next lowest one, 122, next highest one, 153, cancel those. And then I go the lowest one, and then the highest one, cancel those. That's the median, 134. That's the middle number. The mode is most often. Well, there's 134 and 134. It's there twice, so the mode is 134. The mean is I average all those together, and so I just say what's 122 plus 170 plus 153 plus 134 plus 152 plus 134 plus 119 equals, and then I divide that by 7 days, and I end up with 126. Okay, that's number 5. Number 6. Get some more space here. Number 6, use 12 unit multipliers to convert 12,000 cubic meters to cubic yards. So I want to do something and I end up with yards to the third power. Okay, so how do I do that? Well, I'm going to say 12,000 times, this is cubic meters, times a fraction. Well, I know that I know how to convert meters to centimeters. And so 1 meter is 100 centimeters. Okay, but I have to do it 3 times because I have cubic meters. I have meter, meter, meter. So now meter, 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 those will cancel. Now I have centimeters, and I know how to convert centimeters to inches. Well, 1 inch is equal to 2.54 centimeters, but I got to do it 1 inch, 2.54 centimeters, and times 1 inch equals 2.54 centimeters. Again, because centimeters, 3 on the top, cancel the 3 on the bottom. Now I have cubic inches. What this wants is cubic yards, so I'm to multiply, well, 1 yard is 36 inches times 1 yard is 36 inches. I think when they're saying use 12 of them, they're saying convert inches to feet, then feet to yards. This uses 9. It is perfectly acceptable to do it this way. And again, the inches will cancel. The 3 inches there will cancel those. And I'll end up with basically 12,000 times 100, 3 times on the top. And on the bottom, I've got 2.54 3 times, and I've got 36 3 times. Or I could have 3 times 12 3 times. And that would be the 9. This is 9 what we call unit multipliers. The problem says go 12. That would be 12,000. I'll go and show you that since, again, I'm doing this kind of on the fly. This would be 2.54 times 3. And then there's going to be 3 feet in 1 yard. And there'll be 12 inches in 1 yard. So this is where that 36 comes from. So now there's 12. There's 3 there, 3 there, 3 there, 3 there. And that's the answer to that question. So that's using all those unit multipliers to go from 12,000 cubic meters to this many cubic yards. And you would take a calculator and you would multiply all that out to figure out what that is. Okay, next. Problem number 8, or no, 7. It says, what fraction of 105 is 5.5? Okay, blank of blank is blank. So 105 times x equals 5.5. So I'm going to change that to 11 halves. Okay, 11 halves is 5.5. So 105x, divide both sides by 105. And I end up with 11 over 210. And does 11 go into 210? You take it on your calculator. No, it doesn't. So this is the answer, 11 210ths. That's what fraction is. Number 8, very similar to the practice problems, 3 minus a over b over 1 over b minus plus b. Okay, get a common denominator on it's this divided by that. So this one is going to be multiply top and bottom times b, and I get 3b minus a over b. And on the bottom, again, multiply top and bottom times b, and I'll end up with 1 plus b squared over b. So it's this divided by that, which is 3b minus a over b, times the reciprocal of this, so b on the top, 1 plus b squared on the bottom. And these will cancel, and I'll end up with 3b minus a over 1 plus b squared. Answer. That's problem number 8. Moving on, problem number 9. Problem number 9 is going to be similar, x to the negative 1 plus y to the negative 1 over x to the negative 1. So this is 1 over x plus 1 over y equals 1 over x, or divided by 1 over x. Get a common denominator, multiply top and bottom times y, top and bottom times x, and I end up with y plus x over xy over 1 over x. It's that divided by that. What's y plus x over xy times x over 1. X's will cancel, and I'll end up with y plus x times y times 1, or over y times 1, which is just y. Answer. That's problem number 9. Problem number 10 is 4 root 8 minus 3 root 12 plus square root of 30,000. Okay, so this is 4 root 8 is 2 times 2 times 2 minus 3 root 12, which is root 2 times 2 times 3 plus 30,000, which is 3 times 10,000. 10,000 is 2 times 5,000. 5,000 is 2 times 2,250, which is 2 times 1,225. In other words, I'm doing this, 3,000, factoring it, saying, okay, that's 3 times 10,000, and 10,000 is 10 times 1,000, and 10,000, 2 times 5 is 10. 10,000 is 10 times 100, which is 2 times 5, and 100 is 10 times 10, which is 5 times 2, 5 times 2. So I have 1, 2, 3, 4, 5 2s, and I have a 3, and I have, wait a minute, that's a 3. So I have 1, 2, 3, 4 2s, not 1, and a 3, and then I have 1, 2, 3, 4 5s. Okay, so I'm going to pull that out. So this becomes 4 times 2, that's the square root of 2, minus I'm going to pull that one out, 3 times 2, square root of 3, plus I'm going to pull out 1, 2, That's 2 times 2. And then I'm going to pull out a 5. I'm going to pull out another 5. And square root of 3. So this is going to be 8 root 2 minus 6 root 3 plus 2 times 5 is 10. 2 times 5 is 10. 10 times 10 is 100. 100 root 3. Can I combine them? Yeah. Negative 6 root 3 plus 100 root 3 is 94 root 3s and 8 root 2s. That's my answer. That's number 10. Number 11. Notice that this isn't like arithmetic where you just have one problem and you can finish it in like one step. This is just working your way through the problems. Number 11, 2 root 75 minus 4 root 243. Okay, going to do the same thing. 75 is equal to 3 times 25. 25 is 5 times 5. So this becomes 2 root 5 times 5 times 3. 243 is 7 times something. So I think 243 divided by 7 is, nope, 243, what is a 243? What times what gives you a 3 at the end? 1 times 1, 2 times 2, 3 times 3, 4 times 4. Let's try 243. I know divide by 3 goes into it, so it's 3 times something. So 243, how do I know it's a 3? 2 plus 4 is 6, plus 3 is 9. 9 is divisible by 3. So 243 divided by 3 is going to be 81. There we go. And 81 is 9 times 9, which is 3 times 3 and 3 times 3. So this is going to be 4. Root 243 is going to be 1, 2, 3, 4, 5 3s. 3 times 3 times 3 times 3 times 3. And that's what it is. So now I have 2 5s, so I'm going to pull them out. So I have 2 times 5 times root 3 minus 4. And I have 1, 2 3s to pull out. And I end up with a root 3 in the middle. So that's 10 root 3 minus 4 times 3 is 12. 12 times 3 is 36 root 3. 10 minus 36 is minus 26 root 3. Answer. That's question number 11. Question 12. It's going to be 20 and 1/4 x plus 5 1/2 equals 7 and 1/16. And the question is, what's x? First of all, get rid of the fractions. So 20 times 4 is 80. So I have 81/4 x plus 11/2 equals 7 times 16 is, on your calculator, it says 112 plus 1 is 113/16. If I get a common denominator, I don't have to use fractions. So my common denominator is going to be 16. So 4 times 4, top and bottom, that makes this a 16. So I have 4 times 81, which is 81 times 4. So I end up with 324 over 16 x plus top and bottom times 8. 8 times 11 is 88 over 16 equals 113 over 16. So I can just pretend the denominators don't mean anything, and I have this problem. So 324x plus 88 is this, so I have 324x equals 113 minus 88. If I subtract 88 from both sides, that 88 goes away, equals 25. Divide both sides by 324, and I end up with x equals 25 over 324. And that's as much as I can do it, and that's the answer to question number 12. Question 13. Thirteen is negative 3 to the third power minus 2 to the second power equals negative 2 times negative 3k minus 4. Okay, exponents first, so negative 3 to the third power is negative 27. That's negative 3 times negative 3 times negative 3. 2 squared is 4. Minus 2 times this is going to be positive 6k. And negative 2 times negative 4 is positive 8. So a negative of a negative 27 is 27 minus 4 equals 6k plus 8. So this is 23. Subtract 8 from both sides. That will go away. Equals 6k. And so what's 23 minus 8? And that's going to be 15. So 15 equals 6k. Divide both sides by 6. And I end up with k equals 15/6. You can divide both sides by 3 or factor it out, and I end up with 15 is 3 times 5, 6 is 3 times 2, 3's cancel. So k is equal to 5/2. That's the answer to number 13. Okay, number 14, I'll need a little more space. Number 14 says use elimination. Remember we did that last lesson? Elimination, here we go. 5x plus 3y equals 1. And then I have 7x plus 3y equals 5. First step is line them up. They are. Second step is do any of them match? Sure, the 3y and the 3y are both. So I'm going to subtract. I put that out front so I remember what I'm doing. Because 3y minus 3y is 0. 5 minus 7 is negative 2x, and 1 minus 5 is negative 4. So I have negative 2x equals negative 4, so x equals 2. I'm going to then take this and go into one of those problems. I'll pick the top one. So 5 times x, which is 2, plus 3y equals 1. So 10 plus 3y equals 1. Subtract 10 from both sides, and I end up with 3y equals negative 9. Y equals negative 3. That's my answer. 2, negative 3. That's where those two lines cross. That is question number 14. Question 15. I get 5x minus 2y equals 10. 7x minus 3y equals 13. I'm going to now notice they're lined up, x's and y's on top of each other. Equal signs are on top of each other. That's good, but they don't match. So I'm going to look at the smaller numbers, 2 and 3. If I multiply the top one times 3 and the bottom one times 2, it becomes 15x minus 6y equals 3 times 10 is 30. And 2 times 7x is 14x minus 6y equals 2 times 13 is 26. So notice these now match up, 6y, 6y. So if I add or subtract them, I can get rid of them. If I subtract them, it works. Negative 6y minus a negative 6 is negative 6y plus. So this becomes 0. And this minus this just becomes x. And this minus this becomes 4, or x equals 4. So this one's kind of easy. Then I go back to one of my originals. I usually just pick the top one. 5 times x, which is 4, minus 2 times y equals 10. So 20 minus 2y equals 10. Subtract 20 from both sides. I get negative 2y equals negative 10. Divide both sides by negative 2. And I get y equals 5. And that's problem number 15. Again, no way to do this in your head. You have to follow the procedure. The more you do this, the better you'll get at it. But it should be just follow the procedure. Number 16, graph on a number line. X minus 3 is less than negative 2. Well, okay, if I add 3 to both sides, I get x equals, or x is less than negative 1. Okay, so I treat this like an equal sign and just add them. So now if I were to graph this, this is 0, this is 1, this is negative 1, this is negative 2. It's less than negative 1, so that's an open dot with a line that way. So that's graphing it. That's done. Number 17. Whether these are true or false is the set of reals, is that part of the set of irrationals? No. It's kind of the opposite. Reals are all kinds of numbers. Irrationals have only decimals, and they can't be turned into fractions. So a number like 1, 3, those are real numbers. Irrationals are like pi, 3.14157. So these are not part of those. Now these reals also include 3.1415. So these are all the numbers you think of as numbers. Irrationals are ones that are just part of it. So this is backwards. So the answer is this is false. Part B are whole numbers part of the set of real numbers? Well, sure. There. Wholes are 0, 1, 2, and of course reals contain those. So the answer to that one is true. Number 18. Substitution this time. X plus 2y equals 15, and 3x minus y equals 10. Okay, in this one, find one that has x or y by itself. So I'm going to take this one, and I'm going to solve this for y. So I'm going to put y on the other side. In other words, add y to both sides and subtract 10 from both sides. So minus 10 plus y minus 10. So this becomes 3x minus 10 equals y. Now I can take this and substitute it into this one. I'm going to move above it so you can see it a little bit better. So x plus 2 times y, well, what's y? That's 3x minus 10 equals 15. So x plus 6x minus 20 equals 15. Add 20 to both sides, I get 35 on the right. And x plus 6x is going to be 7x. Divide both sides by 7, and I get x equals 5. So x is 5. What is y? Well, remember, y is this, so it's 3 times 5 minus 10. That's 15 minus 10. 15 minus 10 is 5. So y is also 5 in this particular problem. So this is substitution. If you look at question number 14, that was elimination. I generally prefer elimination. There's less having to worry about fractions like here. Where elimination, you don't really have fractions to deal with much. So either way is good, but this one asks you to do it this way. Okay, question number 19. It says graph the equations. So here we have number 19. Y equals negative 2x plus 4. What they're asking you to do is make an xy chart. So if x is 0, what's 2 times 0? 0. So y is equal to 4. And if x is 1, what's 2 times 1? That's negative 2 plus 4. What's negative 2 plus 4? It's 2. So if I was to graph that, 1, 2, 3, 4, 1, 2, 3, 4, 0 over 4 up, make a dot. 1 over 2 up, make a dot. Draw the line. That's it. That's number 19. Number 20, y equals, or y minus 1/3 x equals 2. Similarly, I'm going to go ahead and make an xy chart. What if x is 0? Well, then y minus 0 equals 2. So y is 2. And I try and pick numbers that are easy. I'm going to say, what if x is 3? Then I have y minus, what's 1/3 times 3? 1. So this becomes y minus 1 equals 2. Add 1 to both sides, and I get y equals 3. So now, same thing, make a chart. So 0 over 2 up, that's a dot. 1, 2, 3 over, 1, 2, 3 up, that's my second dot, and that's, well, that's horrible. That's my line between those two dots. That's number 20. Big trick here is if you see a fraction in your equation, pick this number as the denominator, and that'll get rid of the fraction, and it'll make it much easier. Okay, next one. Question number 21. Okay, question 21 is 1 over x squared plus m over x cubed y plus c over y. And what it's asking is write the answers with all exponents positive. So in other words, no negative exponents. This one doesn't have any exponents that are, and you're going to add these together. Well, you can't add fractions when the denominators are different. So this has got an x third, this one's got an x squared, this one has no x squareds. I'm going to make them all have x third. So I'm going to multiply top and bottom times this, and it becomes x over x to the third. Okay, plus this one's already got x to the third on the bottom. And this one, I'm going to multiply top and bottom times x to the third. And so now I'm going to have x to the third on the bottom. Well, this one doesn't have a y, this one does, this one does. So I'm going to multiply top and bottom times y here. Okay, this one's already got an x third y. It's got an m on the top. And this one now has an x third and a y. So this has got a c x to the third over y. So now I have a common denominator, yx third, yx third, yx third. So my answer is going to be yx third, and I've got xy plus m plus cx to the third. Answer. So all the exponents are positive. That's as simple as this will get, which is ugly, but simple. Or should I say simplified? Okay, next one. 2a to the minus 1b minus a to the minus 2b plus 1. I'm going to write it as a fraction. This is 2b over a minus b over a squared plus 1. Same as I did before. I'm going to get a common denominator, and that's going to be a squared. So multiply top and bottom times a. This has already got an a squared. Multiply top and bottom times a squared, and now the denominator is the same, a squared. So I have 2ab, that's that one, minus b, that's that one, plus a squared. That's the answer. Okay, and this is question number 22. 23, simplify 4x to the negative 2, y to the squared, m to the negative 2y. Okay, so I'm going to keep it all on one line to start with. In this case, it doesn't ask you to make negative or positive exponents, so I'm just going to deal with that. So I end up with 4 to the negative 2, x to the, what's negative 2 plus negative 2 is negative 4, y to the negative 4, sorry, you're saying this times this, okay, and we'll give you this. So this times this will give you this, and then m to the negative 2 times y. And so if I'm all said and done, I would typically write this as that, but notice the y's are kind of, I can do, this is y to the 1th. I'm going to say this is 1 over 4 squared, or 16. The x's are on the top. I have y to the negative 4, which is y to the 4th, and a y, and then an m squared. So one of these will cancel with those, and this becomes y to the 3rd. So I end up with x to the 4th over 16, y to the 3rd, m squared. This would be it with no negative exponents. This is okay. I would combine this y and that y to make it y to the negative 3. If you wanted to do it all on one line. That's number 23. Number 24. Both are correct on that one, by the way. Number 24, x to the negative 1, y to the negative 1, all of that to the negative 2, y squared over x squared, all that to the negative 4. So I take these and I'm multiplying them inside each one of these. So this becomes x to the 2nd, and this becomes y to the 2nd. This one becomes y to the negative 8, and this becomes x to the negative 8. If I then rewrite it, x squared over y squared times x to the 8th over y to the 8th, because negative exponent means just make it positive by flipping on the other, and I end up with x to the 10th over y to the 10th. That is question number 24. 25. x to the negative 2, y to the negative 2, p to the 0th squared, and x squared, y squared, p cubed, and all of that to the negative 2. So start with the top. It's just x to the negative 2, y to the negative 2. Anything to the 0th is 1. Anything, so that's it. On the bottom, this becomes x to the negative 4, y to the negative 4, p to the negative 6, because negative 2 times 2 is 4. You get it. And then now some of these will cancel, and I'm going to erase them above it so that I've got more room. Okay, so this becomes, I'm going to put everything where it goes. This goes on the bottom as x squared. It's that one. This one goes on the bottom as y squared. This now goes to the top as x to the 4th. This goes to the top as y to the 4th. And this goes on the top, p to the 6th. Well, this becomes x to the 4th over x squared. Remember, that's just x times x times x times x over x squared. Those cancel. 4 minus 2 is just x squared. So that's those. Similarly, that. And that's the answer to question number 25. Okay, 26. Getting there. Okay, negative 3 squared minus 1 over negative 3 to the negative 3 plus negative 3 to the 0th. Lots of things here trying to get at. The exponent only goes with this. So this becomes negative 9. This, I'm going to put it on the top. This becomes negative 3 to the 3rd power. Instead of being on the bottom, I'm going to make it on the top. Plus, anything to the 0th is 1. So this becomes negative 9. What's negative 3 to the 3rd power? Negative 3 times negative 3 times negative 3 is negative 27. Plus 1. So what's negative 9 plus 27 plus 1? And that's going to be 28 minus 9, which is 19, is your answer. Okay, that is number 26. 4 more to go. Whew. Okay, 27. M minus absolute value of negative m plus n to the negative 2 plus n squared minus square root of m squared. Okay, and the idea is evaluate it if 3m plus 7 equals 1. Okay, so what's m? 3m equals, subtract 7 from both sides, I get negative 6. M equals negative 2. Okay, and it says, and if n is the 5th root of negative 1, well, what times what times what times what is negative 1? Well, n is equal to negative 1. Okay, so evaluate this if this is true. Well, m is negative 2 minus root negative 2 plus n, which is negative 1 to the negative 2 power, plus n, which is just negative 1 squared, minus square root of m, which is negative 2 squared. Okay, well, let's simplify it if we can. Negative 2 minus, all right, what's this ugly thing? This is negative 2 is just 2. And then this is 1 over negative 1 squared. Negative 1 squared is 1. What's 1 over 1? 1. Okay, 1. Okay, and then plus negative 1 squared is 1. And the square root of negative 2 squared is negative 2. Getting there. So negative 2 minus 3 plus 1 minus 2. Well, negative 2 plus negative 3 is negative 5, and negative 7 plus 1. Plus 1 equals negative 6. Answer. Whew. That's number 27. Again, when you do these, you just do it step by step by step and get to the answer. There's no way you'll get that just by doing it in your head. You have to do at least as much writing as I do when I do these to get these right. Okay, number 28. Only 3 more to go. This is negative x squared y plus 3y x squared minus 4y to the third x over y squared x to the minus 1 minus 7x to the negative 2 over x to the negative 4 y to the negative 1. So what I'm doing typically when I look at these is I know I've got fractions, I know I've got things with negative exponents. I'm just going to make everything positive. The other option is just make them with no fractions at all. So let's try making it no fractions at all. So I get negative x squared y plus 3yx squared. Notice these are the same. X squared y x squared. It's the same thing. So negative 1 of those plus 3 of those is 2 of those. I'm already done with that. That's pretty simple. Okay, minus, I'm going to basically say 4y to the third, 4y to the third, put this y up top, that's y to the negative 2, x, put that's this one, and then put this one up here by moving it up top. And now I've got rid of the fractions. So this becomes 4y to the third x squared. Ooh, similar. That's going to work out nice. Minus 7 x to the negative 2. That's 7. That's negative 2. Throw that x up there. Negative 4 is going to be positive 4 if I put it on the top. And then throw this y on top. I get y. And I get, so negative x squared. That's those guys. Y. And notice again, yx squared, yx squared, yx squared. So 2 of those, minus 4 of those, minus 7 of those. Well, that's 2 minus 11, which is negative 9 of those. Answer. So that is the answer to number 28. Number 29. Okay, 29. You have an object like this with a half circle cut in, and its question is find the perimeter. Okay, well that's going to be this side plus that side plus that side plus that side. Okay, so let's see. What does it say? It says this is 6. It says the radius of this is 2, which means that is 4. And that is 6. So it's 4 plus 6 plus 6 plus whatever this half circle is. Well, I know the perimeter of a circle is the circumference. Circumference is 2 pi r. It's half a circle, so it's only just pi times r, which means it's 2 pi. In other words, 2 times pi because the radius is 2. So what's 6 plus 4 plus 6? That's 16 plus that, 2 pi. Pi is a little over 3. So it's going to be a little over 6. So 16 plus 6, it's going to be somewhere around 22-ish, 22 and a half-ish. But this is a good answer. That is number 29. Number 30, last one. Okay, you've got a 3-dimensional object. This is 12. This is 5. This is 4. This is 3. And it's asking for the volume. The volume is the area of a side times the height. Well, area is length times width of a triangle, 3 times 4 divided by 2. That's the area times the height, which is 12. That's the volume. So I can do some canceling. 4 and 2 becomes a 2. 6 times 12 is 72. So that's the volume. And in this case, it's in meters, so it's meters squared. That's the answer. Again, volume equals area of the top or area of the side times the height. In this case, the height is 12. This is lying on its side. The area of the top is base times width times 1/2 of a triangle. And that is done. Whew. Hopefully that helped you. And I haven't gone through every problem that you have for homework in a long time. Rather than just seeing the answer, you can see it worked out here. Hopefully that will help, and I will see you later.